Welcome to my maths presentation. My name is BV Raghuram from class CSE AML section C. Let's go ahead and start with our topic. My topic for today is auxiliary equation, which is used in higher order differential equation solving. And let's start with its definition. Definition of auxiliary equation: an equation obtained from the standard form of a linear differential equation by replacing the right member by 0. It is in form ax square plus 2hxy plus by square is equals to 0. A is equals to 2, 2h is equals to minus 1 and b is equals to k. The auxiliary equation of given lines is in the form of bm square plus 2hm plus a is equals to 0. Auxiliary equation: solving am square e power mx plus bm into e power mx plus c into e power mx is equals to 0. Taking e power mx common, e power mx into am square plus bm plus c is equals to 0. The quantity in parentheses, a quadratic equation, is called the auxiliary equation. This means that to find the solution y, we must solve for m. Am square plus bm plus c is equals to 0. Then m is equals to minus b plus or minus root of b square minus 4ac by 2a. In this table, we can see corresponding part of CF, nature of root of auxiliary equation. Then CF, if one root is real, then the auxiliary equation will be C1 e power m 1 to the power of x. If two roots are real and both of them are different, m1, m2, then c power e to the power of m1 x plus c2 e to the power of m2 x is the auxiliary equation. Then, if three real and different roots are given, m1, m2 and m3, then auxiliary equation will be c1 e to the power of m1 to the power m1x plus c2 e to the power of m2x plus c3 e to the power of m3x. Coming to the second part, if two of the given roots are real and equal, consider m1, m1. Then auxiliary equation is c1 plus c2x into e to the power of m1x. If there are three real and equal roots m1, m1 and m1, then auxiliary equation will be c1 plus c2x plus c3x square into e to the power of m1x. If one pair of complex roots are given, alpha plus or minus I beta, then the nature of auxiliary equation will be e to the power of alpha x into c1 cos beta x plus c2 sin beta x, or it can be written as c1 e to the power of alpha x cos into beta x plus c2, or c1 e to the power of alpha x sin into bx plus c2. If there are two pairs of complex and equal roots alpha plus or minus ib, alpha plus or minus ib, then it is written as e to the power of alpha x into c1 plus c2 into x cos beta x plus c3 plus c4x into sin beta x. If the given roots are one pair of surd roots, then it is written in auxiliary equation as c1 e to the power of ax cos h into x root b plus c2, or c1 e to the power of ax sin x root b plus c2, or e to the power of alpha x into c1 cos hx root beta plus c2 sin hx root beta. Then coming to two pair of surds and equal roots alpha plus or minus root b, alpha plus or minus root b, the auxiliary equation is written as e to the power of alpha x into c1 plus c2x cos hx root beta plus c3 plus c4x into sin hx root beta. This is how the auxiliary equation is written for the given roots to solve an higher order differential equation. Now coming to how do we find auxiliary roots? Simple. Cos t plus I sin t. Thus, if a root of auxiliary equation is r1 alpha plus I beta, then the solution is E into alpha plus I beta is equals to E alpha into cos beta plus I sin beta. Second order differential equation. The auxiliary equation for complex roots. If the equation is am square plus bm plus c is equals to 0, then m1 is equals to minus b plus under root of b square minus 4ac by 2a, and m2 is equals to minus b minus under root of b square minus 4ac by 2. Then m1 and m2 are complex. Then the solution to the auxiliary equation are complex conjugates. That will be m minus alpha plus j beta and m2 minus alpha minus j beta. Case 3. Conjugate complex roots. Thus, the solution to y is equals to c1 e to the power of alpha plus I beta x plus c2 e to the power of alpha minus I beta x is y is equals to c1 y1 plus c2 y2. Then y is equals to c1 e alpha x cos beta x plus c2 e alpha x sin beta x, or y is equals to e to the power of alpha x into c1 cos beta x plus c2 sin beta x. This is the solution for conjugate complex roots. Here we have example for auxiliary equation with complex roots. Y double dash t minus 6y dash t plus 13y into t is equals to 0. For that, we will get answer y of t is equals to e to the power of 3t into c1 cos 2t plus c2 sin 2t. And coming to the second example, y double dash of x plus 25y of x is equals to 0. Y of x is equals to c1 cos 5x plus c2 sin 5x is confirmed when you use the formula discussed before for the complex roots of auxiliary equation. Thank you. Hope you have understood and are able to find out the auxiliary equations accordingly.